All right, let's just jump right in. You know that little supercomputer you carry around in your pocket every single day? Well, what happens when it becomes a crime scene? Today, we're going to go on a hunt, a digital detective's journey, to see exactly how forensic experts pull secrets out of our mobile apps, secrets that are buried deep, deep inside.
So, what does happen when the most crucial piece of evidence is basically invisible to your fancy forensic software? I think a lot of people imagine forensics is just, plugging a phone into some machine and boom, all the answers pop out. But that's really not how it works. The reality is way, way more complicated. The most important clues, the real game changers, they're often hidden in places these automated tools just they can't see them. They don't even know they're there.
Okay, so here's the plan for our little investigation today. We're going to look at the limits of automation, then we'll go hunting for that hidden data. After that, we'll figure out how to decode it, how to prove what we found is actually true, and finally, we'll talk about the single most important tool an analyst has. Let's get started. Right, so every single investigation kicks off with some really powerful, really sophisticated software. And don't get me wrong, these tools are amazing at what they do. But here's the catch, they only know what they've been taught. They represent the current state of research, right? So they're programmed to find what we already know exists. But in the world of apps, which changes like every single day, they can be completely blind to something new or unexpected. And here they are, the big guns of mobile forensics. If you're in the field, you know these names. Celebrate, Magnet Aoxium, Oxygen. These are the tools that do the initial heavy lifting. They're designed to pull just a massive amount of data off a device and decode it. But, and this is the important part, they are just the first step. All they do is lay the groundwork for where the real investigation begins. This right here, this is the whole point. A great forensic analyst, they don't just click run and print out a report. No way. Their job, their real job, begins right at the moment the software throws its hands up and says, I have no idea what this is. That's their cue to go beyond the automation and start hunting for what everyone else missed. Okay, so the software has done its thing. It's extracted all the raw data. Think of it like this. The entire digital crime scene has been laid out for us. Now the real detective work starts. It's up to the analyst, the human, to know where to look for the clues, where the evidence is most likely stashed away.
And these are the places they look. You can think of these file formats as, the digital equivalent of drawers, safes, maybe even hidden compartments behind a bookshelf. See, the data from your apps isn't just floating around in chaos. It's neatly organized and stored in these structured files. Analysts are trained to dive right into things like SQLite databases, property lists, and JSON files, because that's where the good stuff usually is. We're talking messages, locations, call logs, all the juicy details.
And this is why it matters so much. These aren't just hypotheticals. These are real-world cases. Look at this. An analyst digging into a simple navigation app's log file found location data that proved a person was innocent, that they weren't at the crime scene. It completely exonerated them. In another case, a video player's database showed that illegal content had been viewed over and over again. This is the kind of evidence that can make or break a case. And it's exactly the kind of thing an automated tool could have just sailed right past. All right, so we found a file that looks really promising. We open it up and it's just a bunch of gibberish, a jumble of code and numbers that makes absolutely no sense. So what now? Well, the next critical step is cracking the code, translating that digital language into something a human can actually understand.
And there's a process for this, a method to the madness. First, the analyst gathers up all the files related to the one app they're researching. Then they have to figure out what kind of file each one is. Sometimes they literally have to look at the raw code, what we call a hex editor, to do that. Once they know what they're dealing with, they open it up and start looking for clues. And thankfully, analysts get a little bit of help here, because developers often use really descriptive names like message_text or timestamp. They're like little breadcrumbs, little signposts left behind in the data. But, and this is a huge but, here's a crucial reminder for every single analyst out there. You have to be so careful with interpretation. Making assumptions is one of the most dangerous things you can do. Just because a string of numbers looks like a timestamp, that doesn't mean it is one. You have to prove everything. Every single finding needs to be verified. And that, of course, brings us to our next critical step. Okay, we've arrived at what is arguably the most important part of this entire process. This is the validation cycle. This is the step that turns this from just guesswork into actual science. It's not enough to think you know what a piece of data means.
You have to be able to prove it, beyond a shadow of a doubt. And this is how they do it. It's basically the scientific method, but for digital forensics. First, you come up with a hypothesis, just an educated guess about what some data means. Step 2, you create your own test data. You get a clean phone, you install the exact same app version, and you perform the action you're testing. Step 3, you analyze that new data you just created. And finally, step 4, you compare your test results to your original hypothesis. Did it match? If so, great. If not, back to the drawing board. It's this constant loop of formulating, testing, and comparing. Let's make this super clear with a simple example. Imagine an analyst is looking at a messaging app's database. They find a table for calls, and there's a column called direction that only ever has a 0 or a 1 in it. So the question is, what do those mean? The hypothesis is simple. 1 means incoming, 1 means outgoing. So what does the analyst do? They grab a test phone, install the app, and they make an incoming call. And then they make an outgoing call. Then they look at the data they just created. And there it is. The test shows that a 0 means the call was incoming. It's no longer a guess. It's a proven, verifiable fact. So let's recap. We've talked about how software has its limits, we've gone on the hunt for hidden data, and we've walked through how to prove what we find is true. But what's the one thing that pulls all of this together? What's the analyst's most important tool of all? It's probably not what you think. You know, it really starts with a certain mindset. The best analysts have this uncanny ability to, well, to read the matrix. They can look at a screen that just looks like a chaotic waterfall of numbers and letters to you and me, and they can see the patterns. They can see the meaning hidden inside all that noise. And it's also about having this incredible focus and determination. It's about being able to find your prey in the grass field. You have to be willing to sift through literally millions of pieces of irrelevant data just to find that one single crucial piece of evidence. It's a hunt, pure and simple. So here it is, the complete forensic toolkit. You've got your big forensic suites, you've got your database browsers, your hex editors, all the software you'd expect. But look at the bottom of that list. That's the secret. The most powerful, the most important tools aren't things you can download or buy listens for. It's the analyst's own brain and their experience. Which kind of leaves us with this final, really interesting question, doesn't it? If the most important forensic tool is experience, how do you build it? This isn't something you can just learn in a classroom or read about in a textbook. It's built, not taught. It's forged over countless hours of just diving into the raw data, of testing theories that fail, of developing that intuition, that gut feeling that separates a good analyst from a truly great one. In the end, it's the human element that finds the truth hidden in the code.